Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars InSight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe. It looks like a regular beach, but something sets off an alarm blaring in your head. The sand looks too red, the sun is too bright, the wind is all wrong, it's hard to breathe, and there's no water in the ocean. Well, panic not. It's normal, since you're on Mars. For the longest time, we've seen Mars as a dry, lifeless dust ball, a freezing desert where water exists only as ice or vapor. But new research suggests that billions of years ago, it was a totally different place. And instead of endless dust, it may have had something much more familiar to us: sunny, sandy beaches. Scientists from Penn State, UC Berkeley, and Guangzhou University studied radar data from China's Zhurong rover. It started to roll across Mars in 2021. While exploring the surface of the red planet, it found sloping rock formations that looked strikingly similar to the ones found on Earth's coastlines. Those are called foreshore deposits. They form when waves push sand onto a shoreline. But Zhurong wasn't just taking pretty pictures. It also had ground-penetrating radar, a tool that allowed it to scan deep below the Martian surface as it traveled 1.2 miles between May 2021 and May 2022. And it found something pretty wild: layers of sediment sloping down at a 15-degree angle. This pattern is identical to the ones left behind by waves on Earth. And this wasn't from the wind, volcanoes, or anything else. It just looked like a real beach. And that's actually a big deal. Because if there were waves and tides, there must have been a large body of water. That means Mars may have once had just the right conditions for hosting life. Even after 3.5 billion years, The formations are still incredibly similar to beaches on Earth. So there must have been a time when Mars was much more than just a dusty rock in space. After revealing this shocking news, Zhurong's radar scanned 260 feet deep into the ground, discovering sediment layers. They once formed along a path perpendicular to an ancient shoreline, the one that likely existed 4 billion years ago. At the same time, it might not be all that surprising. Back then, Mars wasn't the dry, frozen wasteland we see today. It had a thicker atmosphere, a warmer climate, and plenty of liquid water. And I'm not even talking about some tiny puddle. Beaches don't form without a massive body of water. For waves to shape the land like this, there had to be rivers flowing into a vast ocean. Powerful currents had to be moving sand around, and water had to stick around for a long time. This couldn't be just a brief wet spell. It was a period where Mars was hydrologically active for millions of years, potentially being a place where life could have thrived. This discovery gives even more weight to one theory. It has been puzzling scientists since the 1970s. That's when NASA's Viking spacecraft snapped images of what looked like a shoreline wrapping around Mars's northern hemisphere. But there was a problem. The shoreline was all over the place, with elevations varying by up to 6 miles. Wow, which is nothing like our flat, mostly consistent shorelines we see on Earth. This difference made scientists doubt that a Martian ocean ever existed. For years, scientists have been trying to crack this mystery. In 2007, they suggested that Mars' rotation actually shifted billions of years ago. As the planet's massive Tharsis volcanic region grew, the planet's spin axis tilted, warping the surface. It could explain why the shoreline is so uneven today. In other words, what once was a flat and level landscape got distorted over time. Interestingly, Mars has been dropping hints about its watery past for years. Curiosity found ancient ripples in Gale Crater. There were signs of a long-gone lake. Perseverance is currently studying a fossilized river delta in Jezero Crater. Now, with Zhurong's evidence of an ancient ocean, it all comes together. Small lakes? Check. Rivers? Check. A massive ocean covering the northern lowlands? Quite possibly. Zhurong's mission wrapped up in May 2022 after dust blocked its solar panels. But future missions could still explore those ancient shoreline deposits. Scientists might send new missions to drill deeper into the ground to retrieve samples. Or we could use better radar to map Mars' subsurface in more detail. There's a real hope to excavate those areas in the future and find even more clues about Mars' past. At the same time, NASA's Perseverance rover is already working hard in Jezero Crater collecting samples. Scientists hope that it will bring them back to Earth in the 2030s. While those won't include samples from the ancient ocean, they could still help us find out more about Mars's wetter history. For now, the discovery of ancient beaches on Mars gives us a peek into a time when the planet might have looked a lot more like Earth, with water, waves, and rivers. Now let's speak about the Perseverance rover that's still working on Mars in more detail. It has a special drill on its arm and uses it to scrape off the dust and top layers of rock, making small 2-inch wide circles in Jezero Crater. Once, one of its cameras took a close-up photo, and the image showed that the rock wasn't smooth. It was made of tiny interlocking crystals. The rover used 2 special tools to analyze the rock's chemistry. The results confirmed that the rock, named Rochette, was volcanic. It meant it formed from lava or magma, not from mud and clay, like scientists had expected from a former lakebed. Perseverance, also known as Percy, landed on Mars in February 2021, along with a small helicopter named Ingenuity. It is the most advanced rover ever sent to Mars, following in the footsteps of Curiosity, Spirit, Opportunity, and others. But Percy has a different mission. While older rovers mainly studied Martian rocks and climate, Perseverance is searching for signs of past life. Scientists chose Jezero Crater because it looks like it used to be a lake where tiny life forms could have lived. The rover drills, scrapes, and collects rock samples to study with its science tools. It also saves some samples to bring back to Earth in the future for even closer study. Perseverance has found some surprising things on Mars. Scientists studying the data it sent back have discovered that Jezero Crater has changed a lot over time. Long ago, This area had flowing lava, a lake that lasted for thousands of years, rivers that carried mud and sand, and even massive floods that brought in rocks from far away. It means that Jezero's history is more active and unpredictable than scientists expected. This definitely made it harder to find the sedimentary rocks they were looking for. But it has also revealed new places where ancient life might have existed. Another exciting discovery is that every rock Perseverance has studied so far contains carbon-based materials, the same stuff that life on Earth is built from. NASA's Perseverance rover also carries a special tool called MOXIE, which has managed to make oxygen from the carbon dioxide in Mars' atmosphere for the first time. Over 16 test runs, MOXIE produced about 4 ounces of oxygen. That's enough to keep an astronaut breathing for about 4 hours. It worked even better than expected, making up to 0.42 ounces of oxygen per hour. After running successfully for 2 years, MOXIE completed its final test in September 2023. It brings us one step closer to sending humans to Mars in the future. In any case, back to the discovery of ancient shorelines on Mars. This finding might help us see the red planet with new eyes. Water might have been flowing across its surface for tens of millions of years, carving out lakes, rivers, and even a vast ocean. What else have we misunderstood? Did Martian dinos stroll across the vast green valleys of the planet? Or were those bizarre marine creatures the likes of which we can't even imagine? Well, we don't know yet, but one thing is very likely. Mars had an era of warmth, water, and maybe life.
Of all the creatures on our home planet, this could be the only animal that could survive harsh conditions on Mars. The tardigrade. These fellas have another name because of their unusual looks. Water bears, or moss piglets. They live literally everywhere across the globe, from coastal dunes to mountains, from the lush Amazon rainforests to the barren landscapes of Antarctica. Some live on land, but tardigrades are creatures that need water around their bodies to enable gas exchange and generally stay hydrated. That's why they prefer soil, moss, or leaves covered with a layer of water. And since they're aquatic creatures, they usually choose freshwater bodies like lakes, rivers, and ponds. You haven't come across these cool animals before because they're only 0.02 inches long. You can barely perceive them with the unaided eye. But since they're virtually immortal, we can assume they've developed some amazing survival tactics. If we loaded them in a tiny spaceship and sent them to Mars, they'd be a little shocked at first, especially because of the temperature. Sure, they can live through a wide range, even going below minus 458 degrees Fahrenheit and up to 302 degrees Fahrenheit. And Mars might seem like a very hot planet when you see it in pictures, but the temperatures there are actually low, way lower than on Earth. I mean, it's farther from the sun and has a thin atmosphere, so temperatures there can drop to minus 200 degrees Fahrenheit or go up to 70 degrees Fahrenheit. On Earth, the lowest temperature was recorded in Antarctica. It was minus 128.6 degrees Fahrenheit, while the highest occurred in California, 134 degrees Fahrenheit. Tardigrades are also pretty resilient when it comes to strong pressure. They can take one that's 6 times bigger than the pressure at the bottom of the ocean. Now, for every 33 feet you go down below the surface, the pressure doubles. So, at a depth of 2.4 miles, the pressure is 380 times greater than at the surface. And in the very deepest parts of the ocean, it can be 1,100 times greater. The pressure on the red planet is about 6 times stronger than in the ocean depths. So I guess it's a little bit too much. It would be hard for these little creatures to adjust to such conditions. They would have to evolve through the next few generations to become even more resilient so that they could enjoy their time on Mars more. The food could be one of their main problems though. Some tardigrades mostly eat plants like moss, algae, or some flowering ones, and they like them served with a portion of bacteria. Others are carnivores that eat smaller tardigrades or other microscopic organisms. Well, they'd find nothing like this on Mars. So I guess we'd have to fill their tiny spaceships with lots of stashes of food they would be able to pull inside their tubular mouths. Now we're getting to the really tricky part, water. The red planet is a dry and dusty desert today. But come on, look at all those riverbanks and dried up deltas. Water must have flowed on its surface a long time ago. It's hard to understand where it all went, but it's highly possible most of the ancient water ended up trapped within minerals on the planet's crust. Some older research suggested that most of this water had escaped into space when the sun's radiation had ruined the atmosphere of Mars. But a new study has shown that only a little bit of water escaped, while most of it is still there, hidden and waiting for us to discover it. Also, a few years ago, researchers found signs of hydrated minerals on the slopes of the red planet, where they saw mysterious darkish streaks that seemed to flow. It mostly happens during warm seasons, since they fade when it gets cooler. These downhill flows could be evidence of real liquid water on Mars. Scientists have discovered some minerals that confirm this idea too. These minerals can lower the freezing point of water like salt does on icy roads. That's why scientists think there might be a shallow underground flow of briny water that causes these streaks. Tardigrades probably have excellent instincts, considering they can survive even in the toughest conditions, so they'd probably find water on Mars way before us. But even if they didn't do it right away, they would still have their tactics to stay alive for a while. If this creature loses 99% of its water content, it can survive by pausing most of its vital functions. It can remain in such a state for a couple of years. Tardigrades can absorb extremely strong impacts that would easily crush other animals, including us. They can withstand radiation levels so high that they could destroy a human. And even if we do send tardigrades to Mars one day, that won't be their first trip to space. In 2019, a spacecraft went to the moon, carrying thousands of tardigrades, the first lunar library, human DNA samples, and a DVD-sized archive that contained 30 million pages of information. The idea was to create archives of all the knowledge the human race had collected. But seconds before the spacecraft had to land, the mission control lost contact with it, and it crashed into the surface of the moon. The team was wondering what was going to happen with the spacecraft's cargo. After lots of discussion and analysis, they assumed that the library had survived, and even crazier, perhaps tardigrades had too. They were in this dehydrated kind of dormant state, so they shriveled up into tiny balls. They lowered their metabolism and expelled most of the water from their bodies, waiting for a better environment where they could be their best selves once again. These creatures can stay like this for decades and survive extremely harsh conditions. And this wasn't the first organized tour to space for tardigrades. In 2007, a team of scientists sent a group of these tiny water bears to orbit our home planet on the outside of a rocket for 10 days. They did pretty well, considering that when the rocket got back to Earth, 68% of these creatures were alive. Scientists don't put all their hopes only on these water bears. They keep testing if there are some other life forms that could survive on the red planet. They did an experiment called Biomex on the International Space Station. They took tiny organisms such as algae, bacteria, and other similar creatures and kept exposing them to really tough conditions in space for 18 months. This means things like huge changes in temperature, extreme radiation, and vacuum. The amazing part is that many of these tiny life forms survived these harsh conditions and came back to Earth as true space heroes. So they could probably deal with the hardships of living on Mars. Scientists studied archaea as well. Those are tiny, ancient microorganisms that have existed in salty seawater on our planet for more than 3.5 billion years. Some of their relatives from the Arctic also survived in space-like conditions. But life on Mars doesn't have to be a whole new thing. Billions of years ago, the red planet might have been a bit like Earth. It most likely had water, and that's one of the key ingredients for life. Scientists believe tiny organisms called methanogens might have thrived there. They were hiding beneath the surface to stay safe from harsh radiation. These organisms could have breathed in hydrogen and carbon dioxide, exhaling methane gas. But as they gobbled up hydrogen, which was a powerful greenhouse gas back then, they might have cooled the planet too much. So it's possible these ancient microbes are still somewhere there, trapped in ice deep below the surface. They could be in a sort of deep sleep, waiting for better conditions to wake up, or some new cool friends from Earth. Imagine a world where the red, barren landscape of Mars is transformed into a lush and verdant garden. A world where water flows freely, carving canyons and creating lakes and oceans. Can we achieve such a world by pouring the Earth's water onto the surface of Mars? And don't rush to say no. Let's explore this possibility. Alright, let's say we could magically transport all of the water on Earth to Mars. This supersized game of water pong would be crazy in both engineering and logistics. So how do we even do that? First of all, we're talking about millions and millions of gallons of water, which is no small feat. We would need some really big tanks to get all this water off the Earth. We would also have to figure out how to launch it all into space. This would require some serious rocket technology, as well as a lot of fuel. We could probably create an entire fleet of spacecraft specifically designed for the task. Just imagine that, a fleet of giant water tankers packed with tons of carefully harvested water, blasting off from Earth's surface and hurtling through space at unimaginable speeds. Wouldn't that be a cool sight? Now, another way. Probably a better one would be to launch a large number of smaller missions over time, each carrying a smaller amount of water until enough of it has been transported to Mars. So, let's say we manage to do all that. What happens next? After we get to Mars, we'd need to distribute this water all across the planet. We could use a network of underground pipes or some special drones to transport the water to different locations. This is just some basic things, and as you can see, we already need a lot of planning and resources. Moreover, a crazy operation like this would require a massive coordinated effort from scientists, engineers, and space agencies all over the world. And let's not forget about the costs. No wonder that scientists don't really consider it a viable plan. But the scale of this operation isn't the only problem. Hypothetically, let's say that we figured all that out and poured the Earth's water on Mars. Now what? Well, believe it or not, it would be almost completely useless. Our main challenge will be the atmosphere and current climate of Mars. Mars is a dry desert with an atmosphere that's only about 1% as thick as Earth's. This means that any water poured onto the surface would quickly evaporate. It would be pretty hard to create a stable environment when the entire lake can go poosh in a matter of seconds. And if the water doesn't evaporate, then, on the contrary, it will turn into ice. Mars' surface temperature is well below freezing. Thin atmosphere only makes things worse. Another challenge is that Mars has a very weak magnetic field, which means it has little protection from the solar wind. Solar wind is a stream of charged particles that are constantly flowing out from the sun. These winds are pretty dangerous. They can strip away any water that's put on the Mars surface. Also, the solar radiation on Mars is much stronger than on Earth. This would make it even more difficult to maintain any liquid water there. And finally, don't forget that we also need to purify this water to remove all the bacteria before drinking it. But let's not give up. If we stay super optimistic, we can still try to solve these problems. Basically, we need to find a way to maintain liquid water in one place for a long time and make sure that it doesn't freeze or evaporate. So how do we do it? There are a few ways we can go about it. Number 1, insulation. We could wrap all the water containers in insulation materials, like foam for example, or some reflective materials that can help to keep the water from freezing. Number 2, heating. We could use various heaters and devices to keep the temperatures above freezing, even thermal blankets. Although this would require a lot of energy and would be a difficult task. Number 3, underground reservoirs. We could dig a large hole and cover it with a transparent material to allow sunlight to pass through. This would help keep the water warm and insulated. Number 4, salinity. Adding a small amount of salt or other dissolved minerals to water can lower its freezing point. Although we'll need much more salt for things like lakes, and this method isn't the most efficient. And finally, number 5, building a greenhouse. We could build a greenhouse or some other structure that can trap heat and create a more Earth-like environment. This option is probably the best one. After all, a greenhouse would also help us to grow various plants or other organisms. Yay, life! Alright, great. Let's say we've discovered some way to store water on Mars and keep it there in a liquid, lukewarm state. What now? What impact would this have on Mars? Actually, this would be great. If we were to pour all this water on Mars, it could have drastically changed the climate of this cold, red desert. First of all, we could create a so-called greenhouse effect. It's when gases in a planet's atmosphere trap heat, causing the planet's temperature to rise. And yeah, this is pretty bad for Earth, but for Mars, whose temperatures jump between 70 and negative 200 degrees Fahrenheit, it would be awesome. This could cause the atmosphere to thicken and lead to the melting of the polar ice caps. Wouldn't that be awesome? Mars would begin to gradually turn from a lonely desert into Earth 2.0. It also means that the planet's atmosphere will change. For example, the weather patterns. Clouds could form on Mars, rains would begin to fall. And rains, as we know, transfer water from one region to another, which would mean they could water plants if they appeared on Mars. But all of this is pure speculation. We can't be completely sure what kind of impact pouring water on the Martian surface would have on the planet's climate. Perhaps, to create this greenhouse effect, we would need much more water than what we can transport. But if despite all these challenges, we had succeeded with our mission and made Mars much warmer and moist, could life have been finally born there? Unfortunately, that would still be pretty unlikely. Yes, water is very important for creating life, but that's not all we need. The composition of the Martian soil isn't very conducive to supporting life. The soil is mostly made of minerals called regolith, which are composed mainly of dust, sand, and other materials that aren't very good for plants. Theoretically, we could terraform Mars. Terraforming is a gradual, slow change of the planet so that it becomes suitable for our life, but this would be a very complex, long, and costly process. Oh, and by the way, what would happen to our Earth after all that? We took quite a lot of water, didn't we? From Earth's perspective, transporting water to Mars would require an enormous amount of resources, including energy and different materials. And the amount of water we'd have to spend would be staggering. The loss of such a large amount of water from Earth's own reserves could have a significant impact on our planet, especially in areas where water is already scarce. So basically, this is a really bad idea, no matter how you look at it. Yeah, it may sound interesting, but it's not a viable plan at all. It would require too many resources, too much money, and it wouldn't even be worth it. That's why scientists and space agencies don't consider this idea seriously. Besides, there are many other more realistic and achievable goals in the field of Mars exploration. For example, we can keep studying the planet's geology, atmosphere, and potential for past or present life. These studies would help us to find some resources that could support future human exploration. Overall, we need to answer many more questions about Mars before we even begin to consider colonizing it. So let's keep an eye on scientific news and updates.
And we have liftoff. This is Mars Global Surveyor as America begins its journey back to the Red Planet.
There's a weird structure on Mars, a square. A near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth there were no plants or animals, just microscopic life trying to survive. So Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, hey, everything. wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another Pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock.
How many people do we need to create a new civilization? And not on Earth, but on Mars, and in limited conditions. And if we create this colony and send them off, what problems will they face? How can they survive that far away from home without any support? A recent scientific study sheds light on these questions, so let's take a look at it. Alright, so you want to colonize Mars, right? Well, it's not an easy task. Mars is the fourth most distant planet from the Sun and the seventh largest in the solar system. This lonely red guy is very similar to our Earth. Moreover, before it became a boundless desert, it could well have even looked like Earth now. Millions of years ago, there was water, oceans, plants, and who knows, maybe even life. It would be nice to put all these cool things back there. No wonder we've been talking about colonization of this planet for a very long time. Now, SpaceX claims that their proposed interplanetary spacecraft could deliver 100 people to Mars. The owner of the company, billionaire Elon Musk, talked about creating a fleet that could provide a constant flow of resources to Mars. But how realistic are all these fantasies? Actually, not very much. Before sending people to Mars, we need to solve a number of issues. For example, the incredible radiation exposure, toxic soil, low gravity, low temperatures, and all sorts of other nasty things. And this is just the beginning. It will take at least a couple of decades to create a vehicle that can actually successfully land on Mars and return back. But let's do a thought experiment and imagine that we finally decided to colonize Mars. How will things turn out? Recently, scientists published a new study on this topic. This study is called Minimum Number of Settlers for Survival on Another Planet. The author is Jean-Marc Salati, professor at the National Polytechnic Institute of Bordeaux in France. His article was published in the Scientific Reports journal. As you might have guessed, the study was trying to find out how we could colonize another planet. How many resources do we need? How should this colony live? What kind of work should they do? And how long will it take? And, of course, exactly how many people do we need for all of this? Let's try to answer that. Now, imagine that we've moved into a wonderful future. Well, not really. A terrible future, actually. In his study, Salati suggested that life on Earth was threatened by some catastrophic event, so the only way for humanity to survive is to go to Mars or some other planet. In this imaginary scenario, unfortunately, the supply delivery from Earth was interrupted, or even gone. Now, the colony has to support itself somehow. Well, here's where we already stumble upon a bunch of problems. For example, we're not sure how well the people in the colony will work together. Will they communicate with each other like normal human beings? Will they share their time and resources as they should? Humans are constantly ruining things for other humans. I can even bet that it was their fault we had to flee to Mars. But even if we forget about that, how about organizational issues? What equipment do we have? What will we use to extract resources? What skills would we need? You know what? Who cares? In our case, these things don't matter. All that we know is that the colony doesn't have a lot of initial resources and equipment, and the human factor is absolutely unpredictable. So the chances of survival are pretty low, but we need to survive somehow. In this case, Salati describes two things that will have a huge impact on our survival. These things are essentially variables in a mathematical equation. The first one is the availability of local resources. Basically, it means water, oxygen, and all sorts of useful chemical elements. These resources should be somehow mined and easy to use. Fortunately, we're not starting from scratch. We already know a lot about Mars. What resources are there? How can they be used for life support, agriculture, and industrial production? The colony is lucky because all this has been studied at various seminars and published in reports and books over the past years. Thanks to this, we know what will be available to our colony. For example, we know that gases could be extracted from the atmosphere and minerals from the soil. On Mars, we could provide such things as iron, glass, and even organic compounds. The most important problem here is the service life of the equipment that our new Martians start with. They'll have to get as many materials as possible before the tools break. Keeping them in good condition will be almost the most important task. The second thing is the production capacity, or the speed of work. We have a specific list of things we need to do, make some tools for example, and all this must be produced in sufficient quantities before the literal deadlines. Salati says that the most important thing here will be the so-called sharing factor. Imagine one person trying to survive on Mars. They would have to do all the tasks on their own. They would need to find or build their own system for supplying drinking water, oxygen, and electricity generation. We've already seen how this played out in the movie The Martian. This task wasn't easy at all. There's always not enough time, and all of this is just too much for one person to handle. Unless you're Matt Damon, of course. So, surprisingly, we need a fairly large colony. This significantly distributes the burden. Each person spends less effort, gets tired less, and as a result, the efficiency and speed of work grow. This is where the sharing factor comes into play. Now we need to calculate this number. If we want, for example, to build something, how many people do we need to do this quickly and efficiently? How can we optimize the work as much as possible? Well, it depends on the needs of these people, on available resources, random things like weather, and so on. But in general, this number can be estimated and calculated using some mathematical functions. Salati tells in more detail about these functions in his article. You can read it yourself if you're interested, but in general, he describes 5 areas that need to be taken into account when calculating this number. These areas are ecosystem management, energy production, industry, buildings, and the human factor. The human factor includes such things as the upbringing and education of children, sports, games, music, and so on. In the end, it all comes down to 2 things: how much time we have and how well the people in the colony will work with each other. So, what was the result of all these calculations? In the end, Salati found out that we would need at least 110 people to successfully survive on Mars. This is the minimal number needed to create a self-sufficient civilization. And it will be better if we don't take too many people with us. The more people we take on the spacecraft, the more difficult it will be to predict the results. After all, as we've already said, humans are always ruining things for other humans. So it's better to stick with about 110 people. Of course, this is a rough estimate, and there are a bunch of different assumptions and uncertainties, but even this number is already very useful. Now the scientists know how many people is a minimum for colonization of another planet. Colonizing other planets is a very complex issue, and it will take us a very long time to resolve it. It's very unlikely that we'll fly to Mars in the near future. This task may take several decades, or even a century. Therefore, the best solution would be to try our best to save Earth until we can begin to conquer other planets. There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hogwallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the Red Planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild.